Okay, good evening, guys. I trust and hope you are doing fine. Okay, so we are back with math today, which is Monday. Okay, so today we want to look at what we call as the De Morgan's laws under set theory. Okay, so earlier in the day, I sent some lessons. Okay, I sent a link to our Google Drive. Okay, for you to watch that video on De Morgan's laws. Okay, so I hope some of you watched it because it's going to help us in proving these De Morgan's laws. Okay, so when you talk about De Morgan's laws under set theory, you simply mean this. Okay, so we have two De Morgan's laws, and they are stated in the following ways. Okay, so we are talking about these De Morgan's laws, and then we have two of them. So the first one states that A intersection B, okay? And when you put these in complements like this, it's the same as A complement union B complement, okay? So this is the first De Morgan's law. And then the second one states that if I have A union B, okay, and then I have a complement outside, then this is the same as A complement intersection B complement. Okay, so these are the two De Morgan's laws. So it is a must, okay, it is a must for you guys to know how to prove these two. Okay, you have to know how to prove the first one, you have to know how to prove the second one. Okay, so it is a must. You have to know it because it will definitely come in one of your tests, maybe even the exam. Okay, it's always there. So you have to know how to do what? To prove it. Okay, so how do we prove these De Morgan's laws? Okay, so we prove that the left-hand side is the subset of the right-hand side, and the right-hand side is also the subset of the what? The left-hand side. If you're able to show those two-way proof, then it means you've proved that A intersection B complement is the same as A complement union B complement. Okay, so it's a two-way proof. Okay, so we have to prove that the left-hand side, okay, is a subset of the right-hand side. Okay, so this will be the first part of the proof. And then the second part of the proof will be you showing that the right-hand side is actually the complement of the left-hand side. Okay, and not the complement, I mean the subset. Okay, so if the left-hand side is the subset of the right-hand side, and the right-hand side is also the subset of the left-hand side, then it just means that the right-hand side here is actually equal to the what? To the left-hand side. Okay, so anytime you're given a question under set theory and they ask you to prove if a certain expression is equal to the other expression, okay? If they have not given you any elements and you're just arbitrarily proving them, okay? It means you must show that the left-hand side is a subset of the right and the right is a subset of the what? The left. Okay, so before we even prove this, there are some symbols and terminologies that you guys should be familiar with and what they mean. Okay, I know most of these you know them, but I will go over them just for the sake of those who do not know. Okay, so if you have any questions, feel free to ask. So the first one is this guy here. So what does this guy mean in set theory? Okay, this guy just means member of. Okay, member of. And then what if I have this same guy but with a line there? Okay, so this cross here means that not a member. Okay, not a member of a given set or specific set. Okay, so what other symbols do we have to know? Okay, when proving De Morgan's laws, we have to know this symbol that I was writing. Okay, so this symbol just means subset, right? So it means a group of members belong to an even larger group of what? Sets. Okay, so this one here is the subset. Subset. And then we also have to know the intersection. Okay, so the intersection means we have members that are common in the given sets. Okay, so let's say you have set A and B. Okay, so and then you are told to find the intersection. It means we have members that are common in both what? In both sets. Okay, so here we can say common members or elements, it's the same. And then we also have to know the union. Okay, we know that the union is just combining everything, right? Okay, combine what is in set A. Okay, you also combine it with what is in set B. Okay, so combining everything, okay, in the given sets. Okay, making sure that you do not repeat any elements either in set B or in set B, in set A. Okay, and then one last thing that you have to know, guys, is what we call as the complement. Okay, so if I have, let's say this is set A, and then I say set A complement, what do I mean? Okay, so this can complement some others, just write a line, okay, like this. Okay, some people will write A complement, okay? So this A complement means we are dealing with members, okay? We're dealing with members that are not in set A, that are not, okay, in set A. That's what the complement means, okay? So I'll give you a very practical example. If right now you are at school, it means you are not home, right? Okay, you are absent from home. That's why you're at school. And if you're at home, it means you're not at school. Okay, so the complement means those elements that are not in A. So if A contains 1, 2, 3, and then I have another element 5 that does not belong in the set A, then we'll say that A belongs to the what? To the complement. I mean, we'll say 5 belongs to the complement of A. Okay, because it's not in what? In set A. Okay. All right, so these are terminologies that we are going to be using in proving. Okay, so it's very important to know the following. Okay, if in our proof we change the sign from member of, okay, we change it to not a member of, okay, it means the words, okay, will change. Okay, if we change from not a member of to not a member of, it means the words in our proof, because we are going to be writing words, is going to change. Okay, from and is going to change to what? To or. And then if we change from not a member of, we change to a member of, like this, it means the words in our proof is going to change from or to what? To and. Okay, so remember this when we start proving the De Morgan's law. Okay, right. And then if, let's say I have an element X that is a member of A, like this. Okay, so if this X is a member of A, then what this means is that A is not a member of what? A complement. Okay? The same example I was giving. So if you are at home, it means you can't be in school. And if you're at school, you can't be at home. Okay? So if this X is a member of A, then it means this same X is not a member of A complement. Okay, so if I can show it on a diagram here, if this is my universal set, okay, and then I have set A here. Okay, so this is set A. So if this X is within this set A, it means it's not outside here. Okay, so this here is what we're going to be using in our proof. Okay, so I thought I would give you that hint before we start proving them. Okay, so now let's prove the first one. Okay, let's prove the first one. So we are proving that, prove that A intersection B complement, okay, is the same as A complement union B complement. Okay, so we want to prove that this guy here is the same as this guy. Okay, so I said we are going to do what we call as a two-way proof. We are going to show that this left-hand side, okay, is a subset of the right-hand side. And then we're also going to show that the right-hand side is a subset of the what? Left-hand side. If we're able to show that, then it means that our proof has been what? Completed. Okay, so let's start by proving that the left-hand side, okay, let's start proving that the left-hand side is a subset of what? Right-hand side. So this is the first thing that we are going to do, okay? So how are we going to do, okay? How are we going to do this? So we are going to say let an element, okay, you can choose any letter of your choice, but in this case, let me choose X. So let X be an element that is a member of this first set that we have here, okay? So we have A intersection B complement, okay? So we are saying let X be a member of A intersection what? B complement, okay? So if X is in this complement set, then what does it mean by the complement rule? So remember the complement rule, what I was explaining here. If A is, if X is in A, then it means that X is not in A complement. So in a situation where you have X being a member of A complement, what does that mean? It means that the X is not a member of what? The set A. This is what it means. So this is what we are going to use here. So if X is a member of A intersection B complement, okay, the X is in this set. So it means that, okay, it means that, so you can write then X is not, okay, is not a member of A intersection what? B. Okay, why? Because the X is in the complement. So it's not supposed to be in the intersection of what? A and B. Okay, and then from here we do what we call as expanding. Okay, we do what we call as expanding. So we are going to multiply X and not a member of these two. We're going to multiply these with everything that we have in the brackets here. Okay, we're going to multiply everything that we have in the brackets here. Okay, so we are going to say X not a member of A. Okay, so we are going to say X is not a member of A from this. Okay, and then this sign here, this intersection here, okay, we said the intersection goes with and. So we are going to write this intersection in words. So intersection in words means and, okay? So where there's this intersection symbol, I've put and then I'll multiply this now by B. So X is not in A and X is not in what? B. So that's what we get from this expression here, okay? Okay, and then from here now, okay, from here now, we are going to say if X, okay, if this X is not a member of A, okay, if this X is not a member of A, then what does that mean? Okay, then if X is not a member of A, then it means that X is a member of what? A complement. So remember the rules, right? Okay, and then on the other side, if X is not a member of B, it means that X is a member of what? B complement. Okay, and then remember what I said. If you change your sign, this sign here, where did I write that? Okay, so I said if you change from member of to not a member of, the and changes to what? To or. Remember, okay? And then if you change from not a member of to this, the or changes to what? To and. So there we have a not a member of, okay? This guy here, not a member of, it has changed to a what? To a member of here, okay? So since it has changed there, this and that we had here in between changes to what? To or. Okay, I hope you are following. If you're not, please just ask a question. Okay, so from this expression that we have here, if X is not a member of A, we get that X is a member of A complement. And because we've changed this sign here, okay, it means this and changes to O, and then here we do the same like we did there. Okay, so if X is a member of A complement or X is a member of B complement, what does that mean? Okay, what does that mean? Okay, so this one here means we have X not a member of A complement, okay? And then this union, I mean this O here goes hand in hand with the union. So where there is O here, okay, we can place the union. So we are going to say union, and then here we are going to write the same X is not a member of what? B complement. And then from here, we do what we call as a factorization. So we see what is common between this side here and this side. So we see that X is not a member of X. X is a member of X is a member of Z. It's common on both sides, okay? So we're going to factorize this X is a member of. So we're going to write X is a member of. We have factorized from here and from there. Then what are we going to remain with? We are going to remain with A complement, and then we have this union, and then B complement. Okay, so we see that the original X that was in A intersection B complement is now in A complement union B complement. Okay, I don't know if you've seen that. So remember our original expression here. What did we say? Okay, when we are starting this proof, we said that A is a member of what? Why am I saying A? X is a member of what? A intersection B complement. And then after all these manipulations, we are also finding that this X is a member of what? A complement union B complement. So here it means that we have shown, okay, that A intersection B, then you have a complement there, is a subset of this guy here, A complement union B complement. Okay, so this complement here, you can represent it the C if you want. If you want, you can represent it with that symbol. Okay, so we've shown that A intersection B complement is a subset of A complement union B complement. Okay, so this was the left-hand side, and it's a complement of the what? The right-hand side. Okay, so this is what we have here. So we have just done the first part of the proof. Now the second part of the proof is to show that this right-hand side, this guy here, is also a what? A subset of this. If we're able to show that, then it means the left and the right, they are the same. Okay, so we have done the first part, and then let's go to the second part. So on the second part now, we are proving that the right-hand side, okay, we're proving that the right-hand side is a subset of the left-hand side. So it means we are going to start with what we have on the right-hand side, okay? So remember our expression is like this. Complement is equal to A complement union what? B complement. Okay, so we are going to start with this expression that we have on the right here. So we are going to say let X be a member of A complement union B what? Complement. That will be your what? Your first step. Okay, and then we see that from here, okay, from here, we see that we can expand, okay? We can expand this X is a member of, we can expand it to the A complement, and we can also expand it to the B complement, okay? So we're going to say then X is a member of A complement, okay? And then this union here becomes O, okay? X is a member of what? B complement. So this is what we get from this first expression there. Okay, so now from this second expression here, okay, we said if X is a member of A complement, if X is a member of A complement, then what does that mean? It means that the X is not a member of what? A. That's what we said. Okay, so from this expression here, we are going to get X is not a member of what? A. Okay, and then Okay, I'll jump this. And then on the other side again, if X is a member of B complement, then it means that X is not a member of what? B. Okay, so that is what we have. And then notice that we changed the sign from member of, we have changed it to what? Not a member of. So it means that the symbol here has to change, okay? So this all, we said it represents a union. So it has to change to a symbol that represents that represents the intersection, okay? So this O changes to what? To and, because and represents the what? The intersection. So why is it changing? Because we have changed this symbol from a member of to not a member of. Okay, I hope you're following that. Okay, and then from here, we can actually factor out the X is not a member of, because I can see it here and I can also see it where? There. So what I'm going to do here, I'm going to say X is not a member of, okay? And then in brackets, I'm going to write A, because I've factored out this guy here. I'm going to write A, and then where there's and, I put now the symbol, which is intersection, and then I remain with what? With B. Okay, so from the complement rule, we know that if X is not a member of A intersection B, then it means that X is a member of what? A intersection B, and then complement outside. Okay, so if X is not a member of A intersection B, then it means that X is a member of A intersection what? B complement. Okay, so there we have it. So you notice that this is what we had on the what? On the right-hand side. So our expression was left side, A intersection B complement, and then this was equals to A complement union what? B complement. So we started with an X in this set, and then we have ended with that same X being in what? In this set. Okay, so what does that mean? It means that A complement union B complement is actually a subset of what? A intersection B, and then complement outside there. Okay, so we've shown that the right-hand side is actually a subset to the left-hand side. Okay, so we've shown the two parts of the proof. Okay, so we first began by showing that the left-hand side was the subset of the right, and then now we are showing that the right-hand side is the subset of the what? Of the left. So if you're able to show those two, then we can conclude, okay, that the given De Morgan's law is correct. Okay, so now to conclude, you are going to say that, okay, since the left-hand side is a subset of the right-hand side, okay, and the right-hand side is also a subset of the left-hand side, okay, then, okay, what was on your left? On your left, we had A intersection B complement is equal to, and then on the other side, we had A complement union what? B complement. Okay, and then you write hence proved. Okay, so any questions there, guys, on how we were able to prove this De Morgan's law? Any questions there? Okay, so if there are no questions, that's simply how you can prove the De Morgan's law, which was the first one. Okay, so I proved this one here. Let me write it. We are proving this one here. B complement. Hey, the complement should be outside. We are proving this A intersection B complement is equals to A complement union B complement. Okay, and then the other one is A union B complement is equals to A complement intersection B complement. Okay, so I've proved this. I've shown you guys how to prove this. Okay, so I won't prove this for you. I will give you as an exercise to see if you understood whatever I was saying. Okay, so you prove this guy here. Okay, so just write it down somewhere and then you try to prove it, and then you can send the solutions to my inbox, or you can even send in the group. Then I'll be able to comment if what you're doing is the correct thing or not. Okay, so any questions, guys? Okay, so if there are no questions, I'll end here. That's it for today. We're just proving the De Morgan's law. So make sure you do this one here. Make sure you do it. So I want to see you guys sending answers in the group. Don't just leave it like that. Okay, start learning right now. Because when classes start, believe me, you're going to be under pressure. Okay, because you'll be required to do a lot of things. Okay, there will be tutorials, there will be labs. Some of you even give up. Okay, so to avoid that, start learning what you can right now. Okay. All right, guys. So thank you for coming through. I'll end here. Have a blessed night.
Oh, it's like he was just teaching specifically the model.
Nomba tutor ka subscription fee shinga. Hello.
Hello. Someone was asking the subscription. The classes are free the whole December. Okay. So we'll be having free classes until the whole December finishes. And then thereafter, those who would like to register with us can actually register with us. Okay.